Good morning, everyone. Today, we start an exciting journey into the world of integration and its profound application in physics and the natural sciences. We cannot do all the applications today, at least we'll come to know how to apply integration for physics and for natural sciences. It's a fundamental concept in calculus and not just a mathematical tool. You can say that it is a lens through which we can better understand the universe. What is integration? At its core, integration is the process of finding the whole form, its parts. It allows us to calculate areas under curves, volumes of irregular shapes, and even the total quantities when the rate of change is known. This concept is pivotal in physics and other natural sciences where it frequently deal with continuous quantities. For example, area of regular boundary, all of you know A equal to length into breadth, but why you don't know. If boundary is irregular, then huge problem arise. How to find the area when boundary is irregular, but integration will help you to solve all those problems. In physics, integration helps us describe and predict natural phenomena. Let's look at a few key examples. Kinematics, it will allow us to determine displacement from velocity, velocity from acceleration. See, it is just reverse process of differentiation. Differentiation, you have differentiated to get velocity from displacement. Acceleration from velocity, here it is just opposite. You have to extract displacement from velocity, velocity from acceleration. Even displacement from acceleration, integration helps. If we know the velocity of an object changes over time, we can integrate this velocity to find the object's position at a given moment. Electrodynamics, Maxwell's equation, once more, fundamental to understanding electromagnetism, it relies heavily on integrals. These equations describe how electric and magnetic field propagate and interact with matter. Without integration, you cannot understand all this. Concept of work and heat in thermodynamics, which you will study or studied in class 11 course, require integration. Pressure, volume, or heat capacity and temperature, everywhere it has application. Quantum mechanics wave function are described by using integration. Probability of finding a particle in a certain region is obtained by integrating the square of wave function over the region. Might we have done it or you have not done. I'm just telling you, informing you all these things you can do by integration. Biology, how do you apply? Why bio student will study to get chance in competitive exam? No, in their subject also. Population dynamics. Growth rate of a population can be integrated over time to predict future population size. Chemistry, how do you apply? Reaction rate, especially in chemical kinetics. It involves integrating the rate laws to find concentrations of reactants or products over time. Environmental science used to model the spread of pollutions in air and water, taking into account variables like wind speed, water current, diffusion rate. So many applications are there in integration. You have to learn it properly and then apply the concept in physics, chemistry, and any natural sciences, or should I say any natural processes. You will decide one by one. Today you learn integration with me. Indefinite integration is the reverse process of differentiation. And definite integration means integrate within limits. Like derivative of sin x is cos x. Derivative of sin x plus k is also cos x. So integration of cos x will be sin x plus this k will be referred as integration constant.
Yes.
And definite integration means integration within limits. So the formula you got for cos x dx equal to sin x. In definite integration, we will not put plus k. We'll just put the lower limit and the upper limit. Suppose integrating the expression between 0 and pi by 2. So its value going to be 0 to pi by 2. This is nothing but sine pi by 2 minus sine 0. Upper limit minus 1. This is the process. So definite integration, if you integrate within limits, then it has a value. This is the difference between indefinite and definite. Indefinite integration, we need to put a plus constant over there. Definite integration, we don't put constant. We just integrate within limits. We'll do many on definite integration, few on indefinite integration. But let us develop the formula here in indefinite part. Already I have explained that indefinite integration is reverse process of differentiation and the formula developed accordingly. Cos x dx integration is sin x plus k. Let us see what happens for integration of other factors. Then I will give you the formula. Say derivative of x to the power n, I am writing. It is n x to the power n minus 1. Instead, n I am writing additionally another term ddx of x to the power n plus 1. We are going to develop the formula. Just I am going to show you in one sum how to develop the formula. It is n plus 1 x to the power n. Bring this n plus 1 on left side. 1 by n plus 1 ddx of is equal to x to the power n or ddx of x to the power n plus 1 by n plus 1. Now we apply the reverse process. Therefore, this S-like symbol stands for integration. X to the power n dx, you have to write x to the power n plus 1 by n plus 1. And plus c will be there always, or plus k will be there. This k is integration constant. See, formula derivation is not a subject matter in physics. I just showed you two examples how to get the formula. Derivative sin x was cos x. So integration cos x is sin x plus k. Why plus k? I have explained. The same manner, integration x to the power n is x to the power n plus 1 by n plus 1. We did not keep this form because it is more convenient. After this, I'll be listing formula for indefinite integration. All the formula I'm going to list by putting integration constant over there on the right hand side. So let me write the formula list here. The formula for cos x already we have done. it is sin x plus k. K is the constant, integration constant. If you have done it for sin x, it will be minus cos x plus k, because derivative of minus cos x will be sin x. If you do it for sec square x, this will be tan x plus k, because derivative of tan x is sec square x. So integration of sec square x will be tan x. Cosec square x, it will be just reverse process. Sec x tan x you will not get in physics, rare. It is very rare to get this kind of integration. What you will mostly see in physics, that I'll definitely tell you, cosec x cot x minus cosec x plus k. And then number 7, we go for this one straight. X to the power n dx n plus 1 by n plus 1 plus c. Then if you do it for, and this, remember this k or c, whatever you write, n not equal to minus 1. If n equal to minus 1, this will become undefined. That's why n should not be equal to minus 1. For minus 1, what to do then? For minus 1, it is dx by x. Its value going to be log x plus k or c, whatever you write. C is the integration constant. Because derivative of log x is 1 by x, so integration of 1 by x will be log x plus c. Now, integration of a to the power x, a to the power x by log a base c plus c. Then there will be integration of e to the power x, e to the power x plus c. Additionally, I would like to write one more, which will help you a lot. Suppose you are doing it for dx. This is nothing but x to the power 0 dx, 0 plus 1 by 0 plus 1, the value going to be x plus c. Okay?
Yes.
So integration of dx is x plus c. Other formula of integration, I'll definitely tell you, but let us know the application first. Application is very important. We'll go straight for application, but we have to practice some integration problem, indefinite integration sum, then only we can go there. Let us start. Let us start means these formula based sums we'll do, and there are two rules at your level in integration. So you are writing rules of integration. Let fx and gx be two functions of x. Then integration of fx plus gx, it may be another function. So you can extend it for many functions. Just I'm writing for two here. Number 1, it will be fx dx plus gx dx. If minus sign is there, there will be minus. If you want to extend for many functions like fx, gx, hx, then this will be fx dx plus gx dx plus hx dx. It's very easy to understand. If there is sum of two functions, the integration of sum equal to sum of their integrals. Clear? Now let us do it for another one, another rule of integration. Like, say there is a constant k. This is s. This will not be distorted. Not much distortion will be there. A stands for summation. Integration is nothing but summation. We'll see gradually. That's why this S symbol derived from here. Integration of k into fx dx will be k coming outside, integration of fx dx. This k is a constant over there. Now let us apply this concept in solving a few sums on integration. Like, suppose you have planned to integrate this thing. Integrate number 1 x to the power 10 dx. Number 2 x square plus 1 by x squared dx. Number 3, it is, say, y, and number 4, it is, say, 2 sin x plus 4 cos x dx, and the last one, that is dx by x to the power 40. Okay, so ordinary sums. We'll be using the formula only. The list of formulas should be ready with you always to do sums. Okay, x to the power n. One very important thing I wanted to say, the formula you need most for physics is this one. Is this one. And these two. Mostly you need formula for these four for physics, chemistry, or whatever field is there. These four are mostly required in various forms. Various forms are there, definitely, like substitution in differentiation is there. Here also there will be substitution. We come slowly to that point. Now, let us integrate sums are based on those concepts, mainly, I mean, those formula also. Let us do number 1. I'll be writing the formula. I'll remind you always. X to the power n dx is n plus 1 by n plus 1 plus c in obviously not minus 1 here. So first one, x to the power 10 dx, is simply 10 plus 1 by 10 plus 1 plus c. C is the constant. Integration constant. Clear?
Yes.
For number 2, if you are doing, there is no formula for x square plus 1 by x square. We need to separate. It will be x square by x square plus 1 by x square dx. So dx you keep there plus x to the power minus 2 dx. Dx integration is x. This thing is minus 2 plus 1 by so x minus 1 by x plus c. Clear? Or yes, just x to the power n formula is in use. Let us see why this sum also can be solved by using the same concept. Number 3 we are going to. For number 3, we will cancel the factor. So we need to factorize it. X cube, x equal to 1, the by factor theorem in mathematics, x equal to 1 will make it 0, so x minus 1 is a factor. I'm writing thrice, x squared, x cube adjusted, minus x squared plus x squared adjusted, minus x minus 6. So on factorization, this is changed to x minus 1 these two getting cancelled. X will not be equal to 1. X not equal to 1, otherwise this is not defined only. So this is quite obvious. The remaining term will integrate term by term. X squared dx, x dx, 6 outside only dx. It will be x cubed by 3. Now 3 integrants are there. So 3 integration constants. No, we'll write 1 only. Because this one will give us one constant, say k1. This will give us another one, k2. This one, k3. When they're added, they give just single integration constant, k. That's why we'll write just one constant for whole integration. Okay. Now we'll do it for number 4. Same manner, you split this one as sum of two integrands, fx dx, gx dx. 2 will be outside, sin x dx. 4 will be outside, cos x dx. Sin x integration is minus cos x. Cos x integration is sin x. And only one integration constant plus c. That's why you have written plus c over there. It is the final answer is 4 sin x plus c. Let us do now number 5. Number 5 going to be equal to this thing, x to the power minus 40 dx. This will be x to the power minus, I have taken x to the power 40 numerator. So this will be x to the power minus 40 plus 1 divided by minus 40 plus 1 plus c by this plus c. So answer is minus 1 by 39 x to the power 39 plus c. Done. This is indefinite integration. All these sums can be done by using definite integration also. Just it will be given integrate within limits. Okay, I'm just writing. Integrate, evaluate the following integral. I'm taking few examples like x cube dx. It is from 1 to 2. I'm taking next one, 3 sin x, 4 cos x dx from 0 to pi by 2. I'm doing third one, say it is dx by x square 1 to 2. See how to do this. Just integrate the way you did there, then put upper limit minus lower limit, nothing else.
Yes.
So this thing will be, when you are going to evaluate this one ordinary, first you do indefinite part. C plus 1 by 3 plus 1, 1 to 2. So x4 by 4, 1 to 2. x4 by 4, 1 to 2, just put upper limit minus lower limit. 2 to the power 4 by 4. This is 16 minus 1 by 4. 15 by 4. Clear?
Yes.
This one again you integrate first, indefinite. 3, 0 to pi by 2 sin x dx plus cos x dx 0 to pi by 2. Integration of sin x is minus cos x, formula given. Integration of cos x is sin x given 0 to pi by 2. So put upper limit minus cos pi by 2 minus plus, it will be cos 0. And this will be sin pi by 2 minus sin 0. It's clear?
Yes.
So this will be 3 into minus 1. No, this is minus 0 plus 1. Sin pi by 2, 1 minus 0. This is 4. Value is done. This one, it will be x to the power minus 2 plus 1 by ordinary integration rule, 1 to 2 minus 1 by x, 1 to 2. So this is upper limit first minus the lower limit. The value is 1 by 2. Hope you have understood.
Yes, sir.
You need to practice few sums I'm writing here. Just write integrate number 1, 0 to 1 x4 dx. Number 2, dx by x cube 1 to 2. And then number 3, this is 0 to pi by 2, 3 sin x plus 4 cos x. Okay? You just
Yes.
complete sum. I'll get back to you. That velocity in terms of displacement, v we have written dx by dt. Isn't it? V equal to ds by dt or dx by dt? As your convenience. ds by dt or dx by dt. Because we will derive equations in terms of s. So I'll prefer to write it in terms of s only today's class. That v equal to ds by dt. We remember this. We remember the expression for acceleration, that is dv by dt, or can be written as v dv by ds. Only this concept and little bit idea of integration will help you to derive all the equations of motion. Like v equal to u plus at, when you are going to derive, then definite integration is required. And in definite integration, a to b fx dx, this a stands for lower limit and b stands for upper limit. Okay?
Yes.
A stands for lower limit and B stands for upper limit. In the language of physics, we remember AB this manner, that A stands for some initial condition. Not say some initial condition. This is just initial condition of a process. This is some initial condition, and this one is some final condition. Okay? There will be some initial condition and some final condition in a process. That will be taken as lower limit, initial one, upper limit as the final one. So when you are going to derive equations of motion, you have to remember three equations of motion mainly. Fourth one is actually made of those three. Three equations of motion you are familiar with is number one. I give you the statement. No, you remember it. All of you know this. V equal to u plus at. Particle starts its motion with initial velocity u, moving with uniform acceleration a. Then its velocity is given by v equal to u plus at. U stands for initial velocity and a is the uniform acceleration. Okay?
Yes.
So when you're proving something by using calculus or without calculus, you need to give the proper statement. What is that? A particle starts its motion with initial velocity u and uniform acceleration a. To prove that its velocity after time t is given by this. Okay?
Yes.
Physics is not mathematics. Physics, you need to write some important words. Mathematics is language of physics, but some statement you need to write that you cannot express mathematically. Okay? So when
Yes.
you're going to prove it by using calculus or by using mathematics, you write this manner: a particle starts its motion with initial velocity u and its uniform acceleration is a. To prove that its velocity after time t is given by v equal to u plus t. We are going to prove this. And when you're going to prove any, school-based examination, board-based examination, you need to write this. Okay?
Yes.
So let us derive it now. Particle starts its motion with initial velocity u, uniform velocity a. Now, one thing, before we start calculation, we are sure that this velocity is a function of time t. This is a constant thing. A is constant, then v is a function of t. Okay?
Yes.
So variable quantity. V and t both are variable. V is dependent one, t is the independent one. To derive it, we'll start with the equation proved by calculus. Let us start with, we know that V equal to, no, don't say V. We know that A equal to dV by dt. You know it very well. Acceleration is dV by dt.
Yes.
We are starting with the instantaneous case. That is variable. If you integrate, you get this linear form. So this implies dV equal to A into dt. Now integrating within limits. Integrating within limits some initial value u to final value v a into dt 0 to t. So this integration is v u to v t 0 to t. All right.
Yes.
So there it will be. Why have I taken this? Because u is some initial condition. I told you u is the initial condition, v is the final condition. Particle starts its motion with initial velocity u. After time t, its velocity v. That's why indicating between u to u is the lower one, v is the upper one. So on integration, this will give you v, and this is t 0 to t. Therefore, v minus u equal to at, which implies that v equal to u plus at. Clear? Equation
Yes.
of motion is proved with the help of calculus. I hope this concept is clear. Why
Yes.
integration limit is u to v. It is because of some initial to final condition. 0 to t, initial time was 0. We are considering after time t, that's why 0 to t. Let us go for second one. This time, second one, I'll tell you the statement, but I'm not copying it here. We're going to prove this one is equal to ut plus half at square by calculus. To prove a is equal to ut plus half at square by calculus. We have already proved v equal to u plus at. You can use that equation.
Yes.
Otherwise, you prove it and then apply it. So as it is proved, we'll be using this. But you don't forget to put the statement. That is better way of writing. This is very important. Particle starts its motion with initial velocity u and uniform acceleration starts its motion with initial velocity u and its uniform acceleration is a. To prove that, its displacement after time t is equal to ut plus half at square. Clear?
Yes.
So this will prove with the help of the equation we have already derived. If it is not derived and more than 2 marks given, you have to derive it and then proceed. Okay. So v equal to
Yes.
u plus at. We know that. Let us start from there. We know that v equal to u plus at. Therefore, ds by dt equal to u plus at. So ds is u plus at into dt. U plus 18 to dt. Initial no displacement was there. So we need to put limit at this stage. How to put? We'll be taking this one as 0 to s. This one from 0 to t. So this implies s is equal to u comes outside dt t dt. That is also from 0 to t, 0 to t. We integrate and put the values. That is, here it is s minus 0. This should be t. And this is t to the power 1 plus 1 by 1 plus 1, 0 to t. So a is equal to ut plus, that is ut plus half ut square. This is the displacement in terms of t and derived with the help of calculus. Never forget to give the statement. It looks very good. Let us go for proving now that v square equal to u square plus 2as. So when you are doing it for school-based examination, you give the statement for this number 3. A particle starts its motion with initial velocity u and uniform acceleration a. To prove that, the velocity of the particle after time t is given by v square equal to u square plus 2as, where v is the final velocity. This we have to establish. We have to derive. To prove this one, we start with the expression that acceleration equal to v dv by ds. Therefore, v dv equal to ads. Indicate from u to v. So this one, v's integration will be like integration of x. This time it is v to the power 1 plus 1 divided by 1 plus 1 u to v is 0 to s. This implies v square by 2 u to v. So upper limit minus lower limit concept. You put upper limit here. V square by 2 minus u square by 2 equal to as. So just take u on right side. This is 2as. Therefore, v square equal to u square plus 2as. Done. This is also derived. Now, we'll derive the fourth one. Fourth one means where you have to find the displacement in tth second. Tth second, let me explain. Displacement of a particle in tth second. We can derive it algebraically. Okay, the fourth one, this is not actually equation of motion, but we can refer it as equation. Distance traveled in nth second is u plus half a 2n minus 1. This Sn stands for what? Distance or displacement in nth second. Nth second. I explain. What is that? Again, the same statement, particle starts with initial motion u and uniform acceleration a in a straight line, of course. To prove that displacement of the particle in nth second. This is nth second. This is first second. O to A. If it goes in 1 second, this is displacement in first second. If it goes from A to B, from O to A, then A to B in another second. So O to B in 2 seconds. But this distance travel in second. B to C, another 1 second it takes. This is the displacement in third second. This is in first second. This is displacement in second. This one in third second. This one in nth second. So if you go through all these things, here displacement in first second, if we take as S1, this is displacement in 1 second minus displacement in 0 second. This one, if we take S2, it is displacement in 2 seconds minus displacement in 1 second. If we take this one, S3, it is in 3 seconds minus 2 seconds. If we do it for nth second, this is what? This Sn equal to displacement in n second minus displacement in n minus 1 second. So displacement in n second. Displacement in n second. This is, we know the formula. Displacement in t second is A equal to ut plus half at square. So displacement in n second, you just replace t by n. This will be u into n half a n square minus n minus 1 second u n minus 1 half a n minus 1 square. Put it there. Un, this you take inside bracket and u as common. Then you take half a common. This is n square minus n minus 1 square. Hope you have understood the manipulation here.
Yes.
Just I'm taking all u together and half it together. So now we'll write this thing u into 1. Half a into, you just write 2n plus 1. So u plus half a 2n minus 1. This is for Sn. Okay? Distance traveled in nth second is u plus half a into 2n minus 1. I'm giving you all a challenge to get it by calculus. Prove it by integration. Take this on a challenge. If you can do it, distance traveling nth second, what will be the initial condition, what will be the final condition, that you decide and then derive it. Clear?
Yes.
Now, one thing, all these proofs can be done by graphical method also. All these proofs can be done by graphical method also. Let me tell you graphically how to derive all these equations one by one. For that, we need to plot the graph of graph is required. Graph is most important thing in physics. I'll tell you. Relationship between two observables, between two physical quantities, is better represented in graph. Using equation, it is the language you have to do. But mathematical tool means graph also a mathematical tool. Two or more variables we can easily bring into graphical presentation. Let me do it, all those proofs, by using graphical method. Only one homework you need to do, that you need to think that how to derive it by using calculus. See how I'm proving graphically now those formula. First one, nothing to do. V equal to u plus at. This you can say that I know that uniform acceleration a equal to, no one will ask you in class 11 to prove it by graphical method. As a equal to v minus u by t. So v minus u equal to at. Therefore, v equal to u plus at. Now, this graph has wide application. We'll see that when this graph is plotted, how to plot this graph? It's a problem here. We'll plot the way we used to do in class 9-10 level, only x and y axis. We are taking time along x axis, velocity along y axis. You have to plot this graph.
Yes.
So I'm taking x and y this manner, v versus t. For t equal to 0, it is u. For this, it's symbolic, can be given data, don't worry. So for t equal to 0, v equal to u. For 1, it is u plus a. For 2, it is u plus 2a. Let us start from here. It is, say, u. This part is u. This is coordinate 0, u. Next one, u plus a. I'm giving 1 unit increment or a unit increment u plus a. In 1 second, it lies, it goes there. Its velocity is there. In 2 seconds, its velocity is there. This part corresponds with u plus a. So this length is u. This length is u plus a. And this one we are taking u plus 2a. Now to get the graph, we'll be joining these 3 points. So it's a pure class 9 method or class 10 method, wherever you have done to plot the graph. Graph is done. Now, area under this graph will represent the displacement. Where the concept is developed, how area under the curve, this is the graph V equal to U plus AT. Where have you got the concept? That this will give you the area, this will give you the displacement. Area under the graph will give you the displacement. Suppose after time t, particle is here, this point. Yeah, at time t, so this part is u, this is u plus at. Who told you that this will be the displacement? This is very easy to understand. This one going to be displacement. Why? Because for uniform motion, you know, V equal to S by T. So A is equal to Vt.
Yes.
If you have taken the graph of A is equal to Vt, it is, I mean, this V, this is S, and V is uniform over there. V is uniform over there. So not S, this we are going to plot V versus T. So V is a constant here. V equal to a constant for uniform motion. Starts from there. So this is uniform. V equal to a constant. 1 second, 2 seconds, 3 seconds, 4 seconds, T second. So this is a rectangle. This area is what? This area is this V into this T.
Yes.
And this area represents what? A is equal to Vt is equal to area of Vt graph, and this is equal to displacement. Okay. Any velocity time graph, its area with time axis will give you the displacement. So here also, displacement, actually the whole concept, if I tell you here, then I have to take the help of geometrical interpretation of integration, definite integration. That I haven't done yet. We'll do it in this class. I'll explain how this concept can be extended here. Okay, for this area, this is inclined. You can ask me a question, why for inclined area you are saying this? This I'll definitely explain when I discuss the geometrical meaning of definite integration. For differentiation, it is slope. For integration, it is area under the curve. Why this area also? Displacement, that I've taken one example that in this case it happens, that's why. But I know you are not very happy with this explanation. Why this concept should be explained here? Why when it is not parallel to x-axis? I'll tell you, accept it now. I'll definitely tell you when I discuss the geometrical interpretation of definite integration.
Okay, sir.
So here, area will represent the displacement. So
Yes.
displacement is equal to area of is equal to area of OABM. This trapezium. Trapezium's area half into sum of parallel sides U plus this part is actually V means U plus AT and distance between them is T. So this thing is changed to half into 2U plus AT into T. You just simplify, it is UT plus half AT square. This is graphical proof. So when you are going to prove it for your school-based or board-based examination, you have to write some statement the way we have done it for calculus. Particle starts its motion with initial velocity u, uniform acceleration a to prove that displacement after time t is this. We start with the equation v equal to u plus at. As you know, area under velocity time graph is displacement. So here, displacement is area of this thing, and we have derived. Finished. How to derive from here? If they have given you to prove it, v square equal to u square plus 2s. See, I'm doing here in the same graph by using the same graph only I do to prove that v square equal to u square plus 2as. How to prove this? Very easy. You will say that displacement S is equal to area of OABM. Whose area? The area of this graph. We have plotted this part. V equal to U plus AT. Area of OABM is what? Half into U plus this part is actually V, no? This length is V.
Yes. Yes.
This into T. This is equal to half into U plus V. I'm using this equation this time. This time I'm going to use this equation. What we have started with from here, T equal to V minus U by A. So this will be V minus U by A. Therefore, so it will be V square equal to U square plus 2as. Proved graphically also.